Hello there, I'm Piyush Yadav from ISMT College. So I will be demonstrating my prototype developed for machine learning module. So I have used as regression algorithm models and I'm doing house price prediction. So this first section will import all the necessary library required for our prototype. So let me run it. So the import has been success. And then I have used daily house dataset from which I have used from Kaggle. So I will be importing dataset. So dataset has been successfully imported. This general overview will give the general overview of our dataset. Let's. So this is the general overview of our data. There are 1259 rows and 11 columns. Also 11 columns is also our features. So describe. So this gives us the general description of our data, and then info will give the information of dataset. So there are six feature of data, six numerical feature of data, and five categorical features in our dataset. This is our histogram for our dataset, and this is the heat map for null value checking. This gives us the histogram for our furnishing feature, and the pair plot will give the pairwise relationship between dataset. So here is the pair plot for our dataset, and this data normality section will look for normal distribution. So as you can see, this log transformation section will shows the original distribution of data and after log transformation of data. So the after log transformation, the data becomes more normal distribution, Gaussian distribution. As you can see, this is the QQ plot, which also shows us the distribution of data. So as you can see, the normal original data have much more outliers, as compared to log transform data. And this is checking the skewness and kurtosis of data. As you can see, our data kurtosis, our log transform data is around 3, which means normal distribution. And this is Saprio Wilk test, which also looks for distribution of data. So I'm going to update the data set, as the data set shows more correlated with keeping area less than 3000 and BHK less than 6. Now I'm going to explore and handle missing data. So as you can see, there are 19.98 percentage of data missing in per square feet, 2.70 percentage missing in parking. So we will be updating the missing value. This is the count plot for per square feet feature. So this is going to fill null value with none in per square feet feature, and I am dropping the duplicates, which will remove any redundant data in our data set. Then after removing duplicates, the data set shape is 1104 by row by 11 columns, which was previously 1259 by 11. So as you can see, the parking has been missing value in parking has been reduced to 2.7 for 1%, but previously it was 19.78 percentage. So I'm feeling the parking with the mean value of the parking. Now the missing value has been reduced much more than previous. Then we will be going for numeric features in our data. As you can see, the numerical feature of our data is area, BHK, bathroom parking price per square feet. And this is the subplots for our numerical feature data. This is the categorical feature of data, furnishing, locality, status, transaction, and type. Then I have done label encoding, which will change the categorical data into numerical, which will be more efficient for machine learning, as machine only able to read numerical data. So this shows the correlations among our features. So as you can see, the highest correlated data is area, BHK, and bathroom with price. Also, our target is to look for price. This is the reg plot for our parking and price, then furnishing and price cat plot, which shows outliers. Then I am going to drop this least correlated data features from our data set, that is furnishing, parking, and locality, which you can see below. Then I have done one hit hot encoding, which will assign unique value of the categorical feature by giving dummy variable of 1 and 0. As you can see, all the features has been converted into dummy variable 1 and 0 using one hot encoding. Then our new data set will look like this with one hot encoding. Then I'm giving target array as price, as we need to predict the price of the house. Then I have done scaling, which will bring the data much more closer, which will bring more performance in our machine learning. Then this section will split the data into training and testing. I have used scikit-learn trace net test split method, and the training size is 80% and testing size is 20%, 80-20 ratio. Then this section explains the regression algorithm model I have used. So linear regression, the test and trend evaluation result has been shown for linear regression, which you can see. Then similar for random forest and all algorithm model. This is the N estimators for random forest. Then as similar for ridge and ridge CV, and the evaluation result is shown here. Similar for kn neighbors, the result, evaluation result is shown. Then I have also used gradient boosting, and the result of gradient boosting, which also became our final model, as the evaluation result is more, R2 score of test is much more than other models. Then similar for XGBoost. Then I have also tried to hyper tune the XGBoost, which it will take some time. So the output has came, which will be used for estimating best parameter. So as you can see, the best parameter has been shown, which then I have used for tuning. Now after hyperparameter tuning, as you can, the result, the test and train evaluation result has been shown, which did not show significant result as compared to the original XGBoost regression. Now I have used gradient boosting as my final model because it has more R2A score accuracy of around 83.7%, that is around approximate of 84%. As you can see the actual versus predicted price with gradient boosting, and this is the hist plot of residual of actual price and predicted price of after gradient boosting. Then this is showing the summary of our test and testing. As you can see, the least accurate is linear regression, and the most top model is gradient boosting regression of around accuracy of 84%. Also the cross validation score is shown. Mean absolute error, mean squared error, and root mean squared is also shown. This also shows the comparison between the regression model evaluation. Then I am saving the final model for prediction. Then after providing feature the actual versus predicted price after with saved model is shown, and this saved model has been saved here as house prediction dot job leap. This will be used for prediction on new data points. So this much. Thank you.